come to question 11. Question 11 says, red light bends more than yellow light when going from one medium to another medium with a different index of refraction. When I was talking about the law of refraction, and particularly in the problem where I described, it was question number 6, previously in this test review, I was talking about the critical angle, and I was talking about the phenomena of total internal reflection. I mentioned about diamond, and I mentioned about how different wavelengths of light bend differently in a medium. So this phenomenon is known as dispersion. Dispersion. Okay, when a white beam of light comes from, let's say, air to water, it turns out that the index of refraction of water, earlier I had told you the index of refraction of water is 1.33, but it actually ends up that it depends on the wavelength of the light, right? So it turns out that for the different spectrum of the visible light, we have Roy, G, Biv. This is kind of a way of remembering the visible light spectrum. We have red light, orange, yellow, green, blue, indigo, and violet. This sort of spans the whole visible spectrum. Red light has the largest wavelength, a wavelength of roughly about 700 nanometer. So it's the largest wavelength and the smallest frequency. That represents red. So somewhere between 650 to about 700 nanometer, that's red light. As you get to orange, yellow, green, blue, indigo, violet, the wavelength is decreasing. By the time you get to violet, the wavelength is about 400 nanometer. So it turns out that for red light, which has a larger wavelength, it is affected less by the refraction of light than violet is. The index of refraction of water for red light, let's say, is 1.330. Okay, that's not the exact value, but I'm giving an example here. Index of refraction of water for violet light might be 1.334. So they are different maybe in the third decimal with 0 and 4, something like that, right? So what is that going to mean? Well, that means light slows down, a violet light slows down more in going from air to water than red light does, right? Red light is affected less by the refraction of a light beam, right? So what's going to happen when white light comes from air to water? The red light is going to bend. Okay, we can use the red pen here. The red light is going to bend the least. Then you're going to have orange, yellow, green, right? You're going to have the different spectrum. Okay, orange, yellow, green, and so on and so forth until you get to blue and violet. So we could use the blue pen. Okay, this is blue and violet, right? So the white light is dispersing. Disperse means separating apart from each other. That's why this phenomenon is known as dispersion. This causes what? Rainbow, right? When it rains and the sunlight goes through the water droplets in the sky, we have a rainbow. The white light, sunlight divides up into its spectrum, right? So in this case, red light bends more than yellow? No, false. Okay? False. Yellow bends more, right? By the way, this was why also the diamonds sparkled, because when the white light went there, it split up into its different wavelengths, and then also due to total internal reflection, it kept bouncing forth, and then by the time it came to us, all these dazzling different wavelengths of light came back to our eyes, and we saw a good sparkle. So the combination of the concept of dispersion together with the concept of total internal reflection are the effect of the diamond, right? So in this case, the answer is false.